and always keep track of time so that I can go back to do it later on. All right, because, and then the one thing to do is when you're reading wrong questions, do not get scared. Always just be confident and try to extract as many numbers as you can, as many information as you can, and work your way with it. And another tip for SPM paper is that if you have really have no idea of how to approach the question, you can get from the formula sheet you think which is most relevant, try to work your way and just write your workings down. Even if you do not get the final answer, try to do as much as you can, because more often than not, they award points for that. But that's for paper 1. Paper 2 will be longer questions. We might have to dive into that another day because there are 3 sections, and each section alone, I think, would take up more than an hour or 2. All right. Okay, so that was just a brief overview of how SPM paper works. I'm just going to start with question number 1. So question number 1, if you see past year papers, the topics always repeat. And more often than not, it will be the same topic, but with just iterations of how the questions will be. Right? So if you have a very good grasp of the concept, it should be quite easy to move forward. All right. So question number 1 is a typical question of functions. Right? Usually denoted by fx or gx. Okay. How I would like to think of functions is actually more of say it's I like to see it as like a computer. Okay. Basically, what a function does is that if there is a function in between, it will take an input, or in this case we call it a domain, and then you have an output. We call it range, right? So if you put in 1, say, insert 1 into this function, they'll give you 2. You see, it's like a computer that works for you. But in this case, you have to calculate it yourself, right? So if you get 2, then you put in this calculator or computer, and then out comes 3. From here, you can see that the relationship is just +1, right? It's x plus 1. So in this case, the function is as simple as x plus 1. Where if you put 1 in, you just add 1 and 2. If you put 2 in, you add 1 and you get 3. All right. So that's a very basic understanding of functions, which would help thoroughly throughout the whole paper. Okay. If we were to do question number A, right, to represent a relation in the form of ordered pairs, the keyword here is pairs, right? Pairs meaning it comes in 2s. And if you look at 2 sides of this, there are always 2 pairs, the input and the output. So they just want you to put them into an ordered pair. Just pair them together, right? See the relation and pair them together. Which goes to what? 1 doesn't go to 3, right? 1 goes to 2. So that is the pair. In this case, if you can see, again, just like my drawing, there are 2 lines. There's a function in between that if you put in something, your answer will come out, right? So in this case, the ordered pairs will be -2 and 4. That's one pair. Another pair will be 1, 1. And the third pair will be 2, 4. And just like that, you get 2 marks. Right? Cool. So B, as I said, for me, I usually just look at inputs, but of course there are some theory names to it. And then in this case, the domain would be what you call the input, and the range would be what you call the output. All right. So the domain for this is just -2, 1, and 2. Right? There you have it. Okay. So I think this is pretty straightforward. I will not waste so much time on this. I'll go to question number 2, which is also a function question, right? If you realize, you can see this again. You have 2 sides, an input and an output, a domain and a range, right? And a range. And in this case, fx is x minus 2m, right? X is the number that you put into, and m is the thing that you're looking for, right? So we already know that if you put input 4 into this function, the answer will be 8, right? So if you input, so if fx is equals to x minus 2m, the answer will be 8, right? And then if you input it, there will be 4 minus 2, 4m, right? Just bring it about across the different sides. There will be 4 minus 8. So 2m will be equals to -4, m equals to -2. Right? That's pretty straightforward as well. You should spend very little time on this. The marks indicated on these questions should give you an inkling of how much time you should spend on a question. If the marks is as simple as 1 or 2 marks and you're spending 5 to 10 minutes writing a lot of lines of equation, then you might be on the wrong track. All right, cool. So let's go to question number 3. Okay, so if you can see in this paper, question number 1 and 2 is functions. Question number 3 would be something we often do, it's quadratic equations. Quadratic equations, historically, it is usually a U-shaped graph, like that, or you can go past this, or get past this, but it's always a U-shaped graph, right? There are many things to this, but in the interest of time, I'll just tackle the questions first. And if other questions cover different aspects of quadratic questions, then we can dive deeper into that. Okay, so one of the learnings for quadratic equations is roots finding, right? Roots meaning the numbers of which the curve intersects x-axis. So this quadratic curve has 2 roots, right? Because it cuts off the x-axis at 2 points. This quadratic equation, this quadratic curve does not have any roots because it did not touch the x-axis at all. Okay, sometimes it only touches at 1 point. So then you have 1 root. So basically you only have 3 types. You have no roots, 1 root. This is given by a formula as such. Okay, you have 3 types, right? You have more than 0, equals to 0, and less than 0. If the b squared minus 4ac of the equation is more than 0, that means it has 2 roots. If it's equals to 0, that means you have 1 root. And if it's less than 0, it has no roots. And then in quadratic equation, it is important to know what is b, what is a, and what is c. In all quadratic equations, they come in the form of ax squared plus bx plus c, right? The number, the coefficient, we call it, excuse me, the number that sits next to the unknown x squared, that would be a, all right? And in this case, the number that sits next to x squared is 1 minus a. So that is your a. The number that sits next to x is b, so that's no x squared, that is c. We also call it a constant. C, you can sub it into this formula, right? So minus b would be, sorry, b would be minus 2, so it's b squared minus 4. A would be 1 minus a, and c would be 5. And since the question tells us that there's no roots, that means it has to be less than 0. Right? So then we can carry out our own calculations here. Minus 2 squared will be 4. Minus, you can multiply this, open the bracket and multiply that. So that's 4 minus 4a times 5 is less than 0. And you can continue opening the bracket. 4, so it's 20 minus 20a is less than 0. And then when you open the bracket one more time, it will be 4 minus 20. Minus and minus gives you plus 20a is less than 0. Right? And then you just move around some things. 4 minus 20, that's minus 16, plus 20a is less than 0. 20a is less than 16. Subsequently, a is less than 16 over 20. You can simplify that further. A is less than 4 over 5. And there you have it, your answer. Right? So to tackle these questions, Understand the number of roots. You can have the y-intercepts. They might ask you where the x-intercepts and all these kind of things, right? So it is always key to look for keywords in the questions and try to relate that to your understanding as possible, as much as possible. In this case, the first thing that gravitates me to approach this question as such is when I saw roots, right? When there are no roots, that's when I knew, oh, okay, it should have something to do with b squared minus 4ac. All right, so again, practice is key. Understanding it is one thing, practicing is very important so that you can spot and approach the question as quickly as possible. Okay, so let's go move on to question number 4. Question number 4 looks like a very long question, right? But if you look at the marks allocation, it's only 3 marks. That means you shouldn't spend so much time on this question. Okay, so if you read this, and true enough, they ask you to state. For paper 1 at least, for paper 2 as well actually, if they ask you to state, more often than not, it's often a one-line answer or a one-word answer, and it's just 1 mark for that. There is not much work. But if it's more than that, it's usually probably on the wrong track because it's as easy as stating it. Okay, so for question number 4, say the minimum point. That's this, right? So given this function, fx is equals to x minus 3 squared minus 25. You would think, oh, okay, to find the minimum, the keyword is minimum, I have to go to the ydx and stuff like that. But then you realize doing all those takes up a lot. Should be as easy as just by looking at the equation that's given. And in this case, it is true. Because in this special form of functions, this is one special form of function where you can see x minus something or plus something squared minus or plus a constant, right? These are actually your mean or maximum point, which is the x coordinate will be this number times the negative. So that's 3. Negative 3 is negative, right? If it's positive, then the point will be negative 3. It's just the opposite of it. Okay, so that's the first point, that's the x coordinate, and the y coordinate is just the constant as is. And there you have it. This is your minimum point. So it's just a 1 mark question. It should be as simple as this. The other way to approach this is opening the whole bracket and then perhaps finding dydx to find its minimum and stuff like that, which takes quite a much longer time compared to this. Okay, given there's 3 marks, it should be as simple as this. Okay, so B, the equation of the axis of symmetry. This one is a little bit confusing in my time because it is not very often taught in school, right? But axis of symmetry is where this curve forms a mirror, right? It's usually true the point of the minimum or the maximum because only then it's the same on both sides. Okay, if it is a vertical line and x, you can see this line, right? It's the line of symmetry is always either a vertical line or a horizontal line. Right? More often than not, in this case, for quadratics, it's always usually a vertical line. Okay, and a vertical line, a line that's straight, dead, with no gradient, right? It's always just denoted as simply as x is equals to the point that it is on. And in this case, x is always 3. At this point, x is equals to 3. At this point, x is equals to 3. At this point, x is equals to 3. So the equation of the axis of symmetry is just x equals to 3. In the case that if it's a horizontal line, it's not tested in this question, but if it's in the case of horizontal line, then it's as simple as y equals to whatever. All right, this is just very simple things to know. Okay, and C, the range of values of fx of x when fx is negative. Okay, allow me to erase this. so I can show a clearer drawing. All right. You see, fx curve runs along this, right? So when x is 2, negative 2, fx is 0, and whatnot, whatnot. When fx is negative, that means it lies below the x-axis. That's when fx has a negative value, correct? Everything on top, fx is positive. Okay? So when fx, or y in this case, right? When y or fx is below the x-axis, what are the values of x? Right? If x is, say, the root is 4, right? 8. The root is 8. If x is more than 8, say x is 10, fx is positive, right? That's wrong. You want it to be negative. So it is only negative when it is this portion of the graph. Correct? And what values of x does this portion of the graph carry? Means x should be only until here. Once x passes this range, then fx is no longer negative, right? Therefore, as simple as -2 less than x less than 8. And that is the range. The range, the x has to be less than 8 or more than -2, so that fx is negative. All right? All right, cool. Okay, so I'll move on then to question number 5. Question number 5 is another quadratic question. Very interesting. That's why quadratic equations are very important in this case, actually. Quadratics and functions forms like the basis of every other questions. Even if you go to like log or maybe locus topics, right? Even trigonometry, sometimes there are quadratic equations there as well. It's just a basic, you have to know it. Okay, and as you can see, it always repeats in every SPM papers. So you might want to focus into these areas a lot, where you can bank on the marks. This question, 5a, right? They want to find this one of the roots. Sorry, roots x1 is equals to 2. There might be another root, but it's not given. Correct? Remember again, what are roots? Roots is when the curve touches the x-axis. These are the roots. So if x is equals to 2, here is 2, and here might be another root. I'm not sure what it is. Okay? It might only touch it at one point, but whatever it is given that one root is 2. So if you realize that if the root is 2, what is fx? Or what is the value of y? It is 0, right? Because it is the x-intercept. Roots is the roots of a quadratic equation is more or less the x-intercept of the curve. Okay? So in this case, if the roots is 2, we can take the function 2x squared plus mx minus 5, right? We take this function, and if we substitute 2 into the x values, the answer would be 0. It is like that because it is the x-intercept. If you put in a value into x, it would give out an x-intercept of all you have to do is to substitute the 2 into the x's. Minus 5 is equals to 0. Solve for this, so that's 2 to the power 2 is 4, 4 times 2 is 8, 8 plus 2m minus 5 is equals to 0. 2m plus 3m is equals to minus 3 over 2. Okay? All right. And then we move on to question 5b. This one, the thing that draws me of roots. So in AddMath, we learned something called SOR. There's something called SOR and OR. which is the sum of roots, and the POR is product of roots, right? That means to say if they have two roots, say if the curve has two roots, say 2 and 5, right? The SOR would just be 2 plus 5 times 5. That would be 10. Okay? Just bear with me for a bit. Just understand what SOR is, what POR is. Okay? And then we will go into this this finding that we are taught at school, which is x squared minus SOR x plus POR is equals to 0. This is an equation that holds true. Bear in mind, there are things to note here, yeah? The coefficients of x squared, a, right, is always 1. It has to be 1. And then it holds true. If you do not believe you can try every function, you try to find its roots, and then you add its roots up, you can actually put minus 7x here plus 10 equals to 0, and the function will hold true. It is just like that. It is findings that mathematicians have found, right? So with this this in mind, how should we approach the question, right? This is something you've learned. So then, how should you approach the question? How do you apply it to this question? Given the equation 2x squared plus mx minus 5 is equals to 0, right? You have to bring this down to 1. It has to be 1x squared. That is the theory that we have, right? So we divide each term by 2, right? So that's x squared. Mx divided by 2 would be m over 2x. And minus 5 divided by 2 is minus 5 over 2. It's equals to 0. And then right now, as you can see, this simulates this. It is already mirroring. It's now how you have to compare. Okay? So you can see that m over 2, or actually more appropriately minus m over 2, because it has to be a minus SOR, right? So minus m over 2 is actually equals to the sum of roots here and here. So you can write that down. Minus m over 2 is equals to the sum of roots. And what is the sum of roots? It is given that it is minus 4. So just move it around. Minus m is equals to minus 8. Therefore, m is equals to 8. All right? This is just, I would say, comparing coefficients. These are comparing coefficients. Yeah? Hold up, yeah. Hold on. Sorry, wait. I accidentally closed the app somehow. Hold up, yeah. I'll get back to that. Oh, cool. Oh, not cool. Sorry, technical difficulties. I can't seem to share my screen. Hold up, just give me 1 minute. Can you see now? Left hand, can you see it?
Yeah, I can see your screen.
All right, cool. Okay. So that's done. Let's move on to the next question then. Okay. All right. Okay. This is a question of indices. Okay. There are a couple of rules for indices. In fact, they are actually in your formula sheet, right? But it is best to know it offhand without referring to your formula sheet as much as possible, because that consumes a fair bit of time, right? So I'm just going to lay down some ground rules here for indices at least. Okay. There are some key learnings. That is, if say I have a number A or a term A, right? If I multiply that by A power 3, right? It is actually just A 2 plus 3. So that's A power 5. Okay, and only note that this A is A. You see, in this case, like terms will be X and X. Y and Y will be a like term. 6 and 9 will be a like term. I like to see numbers as like term as well. Okay, so see that A to the power of 2 times A to the power of 3 is actually just A to the power of 5. Alright? And then similarly, if we divide it, that's actually just A2 minus 3. That gives you A minus 1. Okay, do not get confused. Try to be as steady as possible for this one, because more often than not, students lose these 2 marks because they get confused. Most common mistakes I see students do is that A squared times A cubed, they times the number on top. So instead of 2 plus 3, they do 2 times 3. That is a big mistake, because that's not one of the rules, right? So these are two very kind of guarantee that it will come out, or you would have to use this learning in SPM. Okay. And the third one is that there's something like this: A squared to the power of 3. Only here you can A2 times 3. That will give you A power 6. So you see, if you mix this up, then the numbers will be wrong, and then you just lose that 2 marks straight away. All right. So in addressing this question of simplifying, there are 2 things I do. Number 1, try to join like terms. Since you can only work on terms that are like terms, right? If it's A squared times B cubed, you can't do anything. You can't simplify. You can only join like terms. So identify the like terms and join them as much as you can. Okay. One of the one of the hard parts of this question is that you do not know what the right answer is, right? You will never know what the right answer is. There's no way you can check what the right answer is. Okay, so what you can do is just simplify as much as you can until you cannot simplify anymore. Rule of thumb is that you look back at the number 1, right? Number 1 says you have to join like terms. If you simplify it, but at the end there are still terms, there's two like terms. For example, there's two x's that are isolated, then perhaps it has not been simplified completely. Okay, so let's do this question then. First, 6x 4 cubed squared divided by 9x power 5y. First, you want to work on the bracket because brackets are a nuisance, right? They're a problem and they just make you confused. Let's open up the bracket first. Let's to work on each term. Alright? So that's 6 squared. Alright? And x 4 squared, y cubed squared over 9x 5y. So you break that down further. 6 squared is 36. X 4 squared, that's 4 times 2, yeah? Y cubed squared, 9x 5. Alright, cool. So there are still items just illustrated here as a fraction line, right? So they have to cancel out each other. Okay, 36 and 9. They are common factors, they are common multiples, which they can be divided. First thing you want to check is that can a top number be divided by the number below, right? So if, say, for instance, if it's 2 over 3, then that's the simplest. You can't do that anymore. You can't simplify it any further. So basically 36 over 9, you isolate it and see it as a fraction, right? If it's, say, 20, right? If it's 36, or no, say if it's like 8 over 10, you can simplify that to 4 over 5. So you might want to simplify that fraction. 36 over 9 can be simplified to 4. 36 divide 9 is just 4. Okay? And then you isolate the next like terms, x power 8 and x power 5. So this is just x power 8 divide x power 5, right? And then you can see in this learning, 8 divide 5 will be 8 minus 5. So that will give you x power 3. Subsequently, y6 and y1, that is y5. And there you have it, your final answer. Alright? Okay, cool. 4x cubed, y5. Alright. Let's move on to the next one. This is a question for logarithms. Very often, if you see in papers, after indices, you will see logarithms. Correct? Yeah. After indices, you will see logarithms. And indices, after indices, you see logarithms. They always come hand in hand. Okay? In fact, they are kind of siblings or cousins at best. You have rules, right, to adhere to. Logarithms do as well. Okay, and I'm just going to tell you some of the few rules that you have. If you log, say, x, base x, of a number 10, and if your answer is 2, right? What does this all mean actually? I like, if log gets a little bit tough, you can move it around. How do you get rid of this log on the left side and move it to the right side? It's not as simple as dividing log x. Okay? For indices, it works a little bit different. That is, you move the x here. So that would be 10, right? You move the x up, just the base, right? And then this 2 gets pushed up. See that? And then from there, you can straight away see what is the 10. Right? That's how you solve for a logarithm. That's one very important rule of how this I've seen before. Move logarithms by just divide. You gotta do it the way I showed you, right? Move the X up and the 2 gets pushed forward. Up, right? Okay, hold on, yeah. Okay, right? And then there are a couple more rules, but it's not applied in this question or in this paper. I might want to touch on that some other time because in the interest of time, we just want to solve this paper as much. Okay. All right, then I'll also give a little bit background of why. What is the we are just learning the basics of logarithms, right? But if you choose to pursue further or some different particular learning, actually, in fact, anything to do with data, right? One of the usage of logarithms is to simply find numbers. Okay. I give you an example. I'm not sure if you've done data sets before, but they will have a lot of data points, right? Say, person A, his height is 170 cm. Person B, his height is 150 cm. Right? Person C, his height is 200 cm. Okay, these are very easy to handle because the numbers are very small. But right, B is equals to 2 billion, I don't know, right? And then it gets very tedious to handle big numbers. So what you can do is you log a number, log B will give you a smaller number, and then it will be easier to draw a graph instead of bigger numbers. Another usage of log is to solve for curved graphs. Sometimes graphs are curved, right? If you log a curved graph, more often than not, it gives you an approximate straight line, which makes it easier to read data, right? So it's kind of a rule here that once you log a number, the number always gets smaller, right? You can try that in your calculator or anytime. Try logging with any base. Just try logging a number, and the answer will always be smaller. All right. So that's just like I digress. Sorry. Okay, let's go. Right. Given this equation, so as you can see, I actually what you do if you want to find k is that you bring k up, and then 2 gets pushed upwards. So 9 is actually equals to k squared. And then from here you can solve it. It's good if you can see it right away. If you're very good at squares, right? If not, then how do you get rid of squares, right? Okay, you get rid of squares by square rooting, right? You square root. So if you square root one side, you have to square root both sides. So that square root 9 is equals to square root k squared. So the square root of 9 is 3. But bear in mind here that square root of 9 can be either plus or minus 3. But for logarithm, base case, I'm not sure if they can be negative. I don't think they can be negative bases, right? It can be log base 3, but I don't think it can be log base negative 3. Okay? Yeah. All right. So let's go to B. B is a little bit more of moving around. That's where the 2 marks comes in, right? This is just a little bit more thinking. If you can't see it right away, admittedly, I didn't see it right away as well. I think, if I remember correctly, 6 years ago, I actually passed on this question as well because I just couldn't answer, right? Okay, so this, looking at both sides. One way of approaching maths problem is actually looking at one and then try to reach from another side, given another equation or whatnot, another piece of information, and work as much as you can, and then find the answer. Alright, in this case, these two sides is, I'll tell you what it is, yeah. The first part will be log 9 1 over k, the question itself, right? You want to find the ending that's given in the question. Log k 9 is equals to 2. Okay? Let's see how we can work from both sides. From this side, what we can do is, we do log 9. 1 over k is actually just k power negative 1. Okay? Negative 1 means, I'll give you an example, yeah. A power minus 1 is actually 1 over a. A power minus 2 is 1 over a squared. The minus brings it down, but the power stays. Okay? So in this case, 1 over k is k minus 1. You can further bring that down to log 9k. You bring the minus in front. Log, right? Given a root log base a b, say if it's power 3, it's actually equals to 3 log b. Can bring the power down. Yeah. Okay, so it's minus log base 9k, and then you're stuck. You don't know what's the value of this, right? And then that is where you move from the equation given at the start of the whole question. Log k9, log base k9 is equals to 2, right? How can you find log 9k from here? Okay, so for this question, we apply a change of bases. Okay, if you look in your formula sheet, you can change it to base, say this is base 9, right? See this part, I'm working on the left part only right now. This left part, I can work it, change the base to log 9, but it follows this. Log 9, the main number, 9, divided by log 9k. This side is actually equals to this side. It is the same thing. This is equals to 2. Okay? Log 9 is equals to 1. If the base and the thing that you're logging is the same number, the answer is always 1. Log 10 is 1. Log 2 is 1. Right? Log 100 is 1. Alright? Divided by log 9k is equals to 2. And you can see from this fraction, you can actually bring it further, right? You can bring the 2 down and bring the k up. So that's 1 over 2 is equals to log 9k. Times both terms by negative log 9k. And then there you have it, right? This is your answer. So that is what I meant by meeting halfway. So from here you can work all the way back. Just like this question, the answer is negative half. Okay, this might take some time to understand. It's a little bit more playful with log. You have to be really good at logs and the formulas offhand. Then it will be easier to solve this. Yeah, I would say if you cannot solve this offhand, cool. So now we're going to question number 8. We are moving into progressions. Okay, what is a progression? A progression is actually a sequence of numbers. Okay, very often if you take logical sequences or whatnot, you can see what is the next number in that line. Okay, with this learning progressions, you actually get to learn. If we look into this, we actually have two types of progression. There's AP and GP. Okay, AP stands for arithmetic progression, GP stands for arithmetic progression, right? So if the first term is 2 and the second term is 4, third term is 6, what do you think the fourth term will be? So that's 2, 4, 6. The fourth term should be 8, right? And then it goes on. Okay. And then if a GP, you can, if I give you first term 2, second term 4, third term 8, what should be the fourth term? So there's 2, 4, 8, and then that will be actually a 16, and then dot dot dot. Okay. What you can see here is that for an arithmetic progression, the sequences, each number is related by only two types of operations, either addition or subtraction. Okay, either plus or minus. In this case, it's plus 2, plus 2, and plus 2. And it's only called an arithmetic progression if the differences or numbers that are next to each other is 3 or plus 2 plus 3 plus 4, then it's not considered a progression. In fact, I have actually seen an SPM paper as simple as this. They just give a string of numbers and they just ask you to show that it's not a progression. And all you have to do is just check for the differences, right? So you check the second minus the first term. If the answer is 2, cool. The third minus the second term, if the answer is 3, it is different, right? So you just write there, the difference is not the same. All right, it's the key understanding that matters. Okay, and how does AP then differ with GP, geometric progression? Okay, geometric progression, each term is related by something called a ratio, a common ratio, right? It is always worked upon by times or divide. So the operations are only times or divide. In this case, it's constant throughout. It cannot be times 2, times 3, times half, times 0.2, right? It has to note here is, say A is a common term. A stands for the first term. Okay. And in this case, D difference 2. For GP, it's called R, common ratio. These are terms that you have you should be familiar with. A, D, R. Okay. T, N is a T1 for this progression, that is 2. T2 will be 4. All right. Sometimes they ask you to find T100, and that is where the question comes in, right? They wouldn't expect you to count all the way 100 times. You have to use a formula that's given in the formula sheet. Okay. Okay, similarly, it is the same for this one. T, that is T. Then what is S? S would be the sum of the n terms. Okay, if I put sum three, in this case would be first 3 terms. Okay, and just so on. That is what S stands for, basically. Okay, so in this question 8a, right, they're asking you to find the first term of the progression. first term of the progression. You might, they don't give me any sequences. They're not using TN or XN that is given to you as compared, because you should know the common learning system is also equal to S1. It is the first term itself, right? So in this case, with the Sn given, you just sub S1 equals to 5/2. All n's that occur in the question, just sub it with 1 minus 1. There will be 5/2 times 2. 5. Okay? And then look at B. B is a little bit more tricky. This is where they ask you to look for R. Again, you might get scared because you don't know what R is. R is commonly found by dividing second and the first, so 4 divides R, right? But now you do not have the sequences, so what you can do, you use a similar logic that it should be T2, the numbers for T1. What is T2? Okay. Again, if you look at S2, it's actually T1 plus T2. Right? S1 is equals to T1. If you take away S1 from S2, that will actually just give you T2. This holds true for, I give you a sequence 1, 2, 4, 8, 16. Oh no, I give you, for example, a geometry, an arithmetic progression, right? 1, 2, 3, 4, 5, 6. Blah, blah, blah. Okay. Say, sometimes the sum of the 4th to 6th term. They only want you 4, 5, 6, but you're not given this progression, right? But you have to listen that this really just the whole thing here minus this. The sequence of all this minus this alone will give you this. So in this case, you want to find 4, 5, 6, that will just be S6 minus S3. And then you get this portion. Right? It's just simple as taking chunks because that's how sum works. So in this case, you can find sum 2. You can find the second sum 2. S2, right? So S1, S2 minus S1. 3 squared minus 1 minus S1 will be 5, right? So you can do this. 9 minus 1 is 8. 8 divided 2 is 4. 5 plus 20 minus 5 is equals to 15. T2 is 15. So from here, you can know that R is equals to 15 over 5. Therefore, R is equals to 3. I'll give you a minute. All right. Okay, is the connection better?
Yeah, I think the connection is much better right now. Just now it's a little bit laggy.
Okay, cool. Let's say if it's laggy, just say something straight up.
Yeah, okay.
Thank you. All right. Okay, so it's past an hour actually. Maybe a 2 minutes, 3 minutes break to absorb what you have. So, okay then, I'll continue. Yeah. All right. Okay. So we'll go to question number 7. Is it better now, Latian?
Yeah, okay already.
Okay. Sorry, we are done with question number 8. We'll go to question number 9. All right. So number 9 is another progression question. And if you look at it, this question straight up, you can see it's 3 marks for 3 questions. And they ask you to state. Right? So state, then it becomes easier, right? You do not have to do much working. Okay? So then if you look at this question, A, 9A, right? The angles of the sectors form a progression with the first term of 24. State whether the progression is an arithmetic progression or a geometric progression. You see, this is as simple as just stating whether it's an arithmetic or a geometric. You know the two main difference, right? Sorry, the main difference between the two progressions. One is plus minus, the other one is times divide, right? So for plus minus, you can just check the numbers, the differences. 24 minus 30, that's 6. 36 minus 30, that's 6. Since there are 2, is enough to say that this is an AP. You can go on to check if it's a GP, but I wouldn't recommend so in the interest of time. Because since you already confirmed that 6 and 6 is the same difference, and the question kind of states that it should be either one. So then if it's AP, means it's AP. There's no way it can be a GP. Right? In some cases, it can be both an AP and GP, but it's very, very rare. Okay? In fact, I don't think SPM will ask this type of questions. Right? So only if AP does not fit the criteria, right? Say if this is 6 and then the other is 10, and then you might want to check for GP, right? So you can check 30 over 24, and you want to check 36 over 30, and all that. If the ratio or is the same, then it is a geometric progression. Okay, but yeah, that's as simple as that. Okay, then we go on to B. Find the value of P. So you already know that each term just adds 6. 24 plus 6 equals 30, 30 plus 6 is 36. What is P? So it's just, P would just be 36 plus 6. Give you 42. Right? Very straightforward. That's why paper 1 is the paper that you try to score as much as possible, because paper 2 is, to be honest, considerably harder than paper 1. Okay, a lot of workings, and then you get scared halfway, and then the workings are so long, you might get confused along the way, right? It's kind of like a mess for paper 2, to be honest. So try to bank as much as you can for paper 1. Okay, and then you want to find the sum of all terms now. As you can see here, there's actually 1, 2, 3, 4, 5, 6, 7, 8. There are 8 terms. You can see in this, right? There are 8 terms. So the sum of all terms actually just as 8. Okay. The formula for sum is actually n over 2a plus n minus 1d. Yeah. Yep. That's the formula. Okay, so it's best if you know every term. N is the n term, sub in whatever n numbers you want to look for. A is the first term, N is again N, D is the common difference. Okay, this is for AP. Yeah. Okay, so Sn, so S8 would be 8 over 2 times 2 plus the first term 24 plus 8 minus 1, and D would be 6. Alright, so then you carry out S8 will be 4, 24 times 2 is 48, plus 7 times 6 is 42. 48 plus 42, that will be 90, and then you get 360. That will be your answer. Honestly, this is one way to go about it. But if you want to look at this logically, I mean, understandably, this is maths, right? You might want to show as much maths learning as you can. But to be honest, when I did this question, I'm not sure if I did it the maths way. But what I saw was this is actually a circle, and the sum of all terms should be 360 degrees. The answer should be just as simple as 360 degrees. But I think since this is an AddMath paper and they're asking for this in the form of progressions, right? You might want to just write out the answers like that. Right? I mean, that might give you the mark. You don't want to risk it, right? Cool. Okay, so then we go into question number 10. Question number 10 is an example of how long questions can scare you off, right? If I see this long question, it is quite fortunate there's 4 marks, right? If it's a long question and it's only 2 marks, I might skip it straight away and to come back to it, not skip it entirely, but to come back to it at a later time to focus on my energy on answering the questions that I can see offhand at first, right? But never mind, we'll try to tackle this problem as structural as possible, okay? So the first tip, if you can understand it at one go, then that's good. You can know what the learning is and then you can just do your answer. But if you can't, right, and then you come back at the end of the paper and you realize, I still can't do it. What you should do is try to extract numbers from the story, right? Numbers are very important. After all, it's a maths paper. Numbers are still the key, right? Numbers or any equations or things that you have seen in your learning in school before, right? So you look at this. Adam has just completed his diploma in engineering field. That has nothing to do with what you're learning at all, right? So you filter that out. Try to just extract the numbers. So you got 36K here. You got 5% here. Yearly increment per annum, right? So it's an increment of 5%. 36,000 is an initial salary. Okay, that's done. So you have 36 and 5%. What else do you have? All right, then you move on and then you see, oh, another initial salary of 30K and a 9% yearly increment. Again, numbers, right? 9%, 30K. And then Adam decided to choose working in a company which offered higher income and saved 20% of his salary, another number, after working for 10 years, another number. There you have it. You only have 2, 4, 6 numbers, okay? And some of them come hand in hand, like 36,000 and 5% came hand in hand, and then it's repeated with 30,000 and 9%. And then you try to see what you can do from. When I did this, I saw it straight away. It might require practice, but keywords like initial and a yearly increment means it increases every year, right? And you have an initial. This reminds me of a sequence. It's just a progression, right? It's a geometric progression. So that is A, the first term would be the initial salary, right? What would the R be? Since it's 36K times R, right? Times R times by what? It's actually times by 1.05. That's 5%. 5% is 0.05 actually, but you must add 1 to that number because it increases on top of that, right? It's not 36 and then you take 5% of that. It becomes very small, you see? It's 36,000 times 36,000 plus 5%, so it's 1.05. Okay, so you already got A and R for the first one, and then you can see these links together, right? A equals to 30,000, R is equals to 1.09. Okay, and then what's your N? How many times must you do it for? Right? He's working for 10 years, therefore your N is 10. So you got A, R, and N already. And then don't forget to read the question, right? That's the most important. The main question what they're asking for. Which company should Adam choose? And how much is his total savings? So now you got 2 options, right? You get a job that gives you 36,000 as your first pay and a 1.05 increment every year for 10 years. That's option A. Option B is 30K, 30,000 at first times 1.09 and so on for 10 years. Which one pays more? So you want to get the sum, right? Oh, sorry. Okay. So how do you compare? You find the sum, right? So let's do for A first. What is the sum then of A? The sum formula is Sn equals to A R power n minus 1 or over R minus 1. Or in this case, because R is bigger than 1, right? R is 1.05 or 1.09. If R is less than 1, then it will be A 1 minus R power n over 1 minus R. Yeah. Letian can verify formula?
Yeah.
Correct, right?
Correct.
Okay, cool. Sorry, because I don't have access to the formula sheet right now, so I'm making it from memory, right? Okay, so S10 A. So what's the sum of 10 years for the first job? So you can do it. It's 36,000 times R, that will be 1.05 power 10 minus 1 divided by 10 minus 1. Okay, let me do this on my calculator. Oh, sorry, 1.05 R. This is 1. Wait. R minus 1 is 1.05 minus 1. So the answer is 452,804.13. Similarly, S of 10 for B would be 30,000, 1.09 to the power of 10 minus 1 divided by 1.09 minus 1. And that would give you, that should give you an answer of 455,788. Okay, so right off you can see that the second company pays, or at least the second company in 10 years time will be better off than the first company. All right, and then you think to yourself, okay, cool, I think I can make a decision now. then always go back to your question because it's a long question, you get a lot of information, you tend to forget stuff, right? Let me give you an example of what students forget. That's why it's very important to write down whatever numbers you can from the information. Then you can see. You wrote down 36, you use that, correct? You wrote down 5%, you use that. 30,000 you wrote down, you use that. 9% you use that. 10 years you use that. What number do you not use? This one, right? 20%. And then somehow for SPM, more often than not, they will always use all the information in the paper. Okay, this might get trickier in say A levels because I took A levels. In STPM also, understandably so, that they will give you over information and you only use some key one. That becomes very tricky. But for this SPM level, they usually use almost all of the information that's given in the question. That's why extracting the information is very important because you would use it. If you do not use it, like say if they give you 6 numbers and the method that you're doing only use 1 number, you are probably on the wrong track. Yeah. Okay. That much I can say for SPM MS level at least. Okay. So what do you do with 20%? So you read the question again. Which offered higher income and saved 20% of his salary after working for 10 years. So after working for 10 years, this is how much he would have earned, right? But he only saves 20%. So what is his total savings? So you just get for company A, his total savings will be 20% of the total, 452,804.13. That's equals to 0.2 times what not? 452,804.13, and then you get your answer. B would be 20% of 455,788 is 0.2 times 455,788 equals to whatever answer. There you have it. You've done your question. Right? Cool. Cool. All right. So I hope longer questions will not trouble you in future. Try to approach it with confidence. Do not get scared. Do not get scared. One thing is getting scared in SPM papers that worries me a lot usually, because me myself get scared sometimes, especially when the first question is very hard, right? The first functions, if you've never seen it before, right? And then you get scared. Truthfully speaking, if you go up all the way to the first question, where I thought about this mapping, right? I hardly do mapping in school. All we did in school was just formulas, right? Fx, Fx, X, Fx, map onto itself and all that. I've never seen things like this. So ordered pairs and domains and ranges, I wasn't really sure what it was. It was all theory. I wasn't that good with that, right? I didn't focus on that. I focused more on the maths aspect. So I got scared for this. But what I reminded myself that, hey man, you can't be scared. Skip this first, approach other questions and come back to it. True enough, when I came back to it, I was in a fresher mind. I had more confidence because I answered other questions better, and it was easier to solve this. All right, so that was, I digress again. That was just a little bit more of my experience, I would say. Okay, so let's go to question 11. Again, question 11 looks like, whoa, such a long question, but you see it's only 3 marks. If you look properly, it only asks you to state. So then, you shouldn't spend too much time on this. It should be a relatively easier question, something that does not require that much calculations. Okay? Anyway, we are moving into the territory of linear forms. Okay? What are linear forms actually? In our learnings, we have only learned curves that are straight lines, y equals mx plus c, right? That's important, by the way, y equals mx plus c. Sometimes we learn quadratic curves, x squared plus bx plus c, ax squared, right? Sometimes, to some extent, cubic curves, right? Like a shape like that. But you in further studies, right, you might learn curves that are like that, or stuff like that, okay? Stuff like that. So what they want to do is to convert it into a straight line. Of course, logging it is one way. In fact, in linear forms, some of the popular questions will be, instead of y, it will be log y here. Yeah, okay? They will make it a straight line. All right? So in this case, the equation given is xy is equals to 4x minus 2x cubed. Okay? This is not a straight line curve. You see, it has power 3 here, and then it's an xy. I don't know how the curve looks like, okay? But it's not a straight line, right? But then diagram 11 shows the straight line PQ that can obtain by plotting y against x squared. Means if they plot y against x squared, they actually get a straight line. So the first question asks you to express this equation in its linear form to obtain the straight line graph shown in diagram 11. So that should be relatively easy. That means if they give you a diagram like that, there's two types of questions they'll ask from this. They will always give you an equation that's not a straight line, that's a very hard equation. And they will always ask you to change it into a form of a linear form, right? And there are two ways that they can ask you to change it to a linear form. First is they give you a diagram, and they expect you to change it according to the diagram, or they give you straight up another equation. Right? They give you another equation, and then you just have to change your equation to be exactly that equation. Okay, so you move that by dividing and times and whatnot. So if it's diagram, in this question is diagram, right? You look at the diagram of the y-axis and the x-axis. In the y-axis, you have y. Okay, so the first thing you do in this slide is you just put y and put equals. Whatever is on the y-axis, it could be log y, then you just put log y equals. And then you know something, 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 x squared. Because the x-axis is x squared. So your equation, your final equation, should be something in this form. All right, y equals, or log y equals, or xy equals, or something equals, right? Whatever's on the y-axis equals, and then blah 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 whatnot, and then the x-axis. This blah 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 means there are numbers or other things in it. Okay, so if you want to change from this main messy equation to this cleaner equation, what do? First, again, you try to get one term first. You have two terms here, right? You have y and you have x squared. Try to get y first. How do you get y from here? There's already a y here, but it has something attached to it. You have an x there. How do you try to isolate it and make it y first? So in this case, you just divide every term by x, right? Divide by x. So then you get y, because xy divided by x is equal to y. 4x divided by x will give you 4. And then 2x cubed divided by x will be 2x squared. And the answer is just that. It came out straight away. You see, it is in the form of y equals to blah 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 whatnot x squared. Right? You can rearrange this, y minus 2x squared plus 4. So that's your answer actually. It's done. Okay? Then we go into B. B is just stating, but it needs understanding. Okay? The special thing about linear form is that everything in a straight line should have a y equals mx plus c. Right? So this equation, even though it's not y and x specifically, y equals mx plus c, but they are on the y-axis and the x-axis. So you can compare them, right? So this y will be big Y. In some cases, it can be log y as well. So log y will be y, right? But in this case, it's y lah. Just y. Y is big Y. Minus 2 is m, that's the gradient. X squared, since you already see x squared on the x-axis, right? X squared is big X. And then the constant, the one that has nothing next to it, is the constant c. So from here, you can see that the y-intercept is 4. And the gradient is minus 2. That's that. Therefore, you can answer straight away. State the gradient of the straight line PQ. The gradient is equals to m equals to minus 2. Subsequently, the coordinates of P, the y-intercept is 4, right? But they want the coordinates will be 0, 4. Straightforward enough, right? Coolios. All right. Okay, so we move on to the next question. That's the answer. Okay. Again, we look at this question, it looks long. Graphs again. All right. And then they ask you to find the y-intercept of PQ. So this line, what is the y-intercept? But it's Q, right? So given this equation of PQ, you might want to, or you have to open up again, right? Multiply by 7, multiply by 5, make it into like y equals mx plus c, then get c, correct? But no, we looked at the marking scheme again. How many marks was allocated for this? Only 3 marks. That should be 1 mark here, 2 marks here. So a 1 mark question shouldn't be as hard as opening it and y equals mx plus c and then finding c. Sometimes it might. Sometimes it might. If you really can't find any other way, just do that. But in this case, the quadratic or the straight line equation is actually given in a very interesting manner. X over 5 plus y over 7 equals to 1. This equation is in the form of x over a plus y over b equals to 1. Right? Where this a is the x-intercept and this b is the y-intercept. So in this case, the y-intercept is straight away 0, 7. Or 7, I think. 7. Just 7. Right? Because it is in the form. It is in that form. It's a special form for straight lines. Alright? Okay. And then B. B gets a little bit tougher because it's a 2 marks question. Given this length, okay, if I draw it on a straight line, they'll always give you 3 points. Alright? A, B, C. Sometimes they'll give you A and B and they ask you to find C. Sometimes they give you B and C, they give you to find A. Right? Sometimes they give you A and C, they ask you to find B. Okay? And then they always give you a ratio 1 to 2, 2 to 3, or 1 not. Okay? So in this case, they give you A and B, right? A is 3 minus 4, B is 5, 0. Okay, this is confusing. So A, P, and B, right? I'll follow the question. And then they ask you to find B. And the ratio given is that BP is 2 times of PA. So here is 2, here is 1. So 1 PA, here is 2 PA. 1 and 2. Okay? If you look into your formula sheet, you can see this formula here. This one. Okay? The point in the middle is equals to x1 times the ratio that is opposite plus x2 times the ratio that's opposite. Okay, let me show you how it's done. So it's 5, 0, the point in the middle, is equals to, so B, so B is an unknown H and K, right? So B is HK, the coordinate is HK. You don't know why this can be CD or whatever you want it to be, right? So HK. So the coordinates HK, here's 1, here's 2. To find this one, the formula is h times 1. So x times 1 and this x times 2 cross. This is plus 3 times 2 divided by the ratios 1 plus 2. 1 plus 2. So then that's for x, and then for y, you do the same thing. K times 1, you cross it, right? K times 1, and then minus 4 times 2. Plus minus 4 times 2. Divided by, again, 1 plus 2. So you can see this is actually just comparing again. X is x, y is y. Okay, so 5 is equals to h plus 6 over 3. H plus 6 equals to 15. H equals to 9. Then for y, this is for x, right? For y is 0 is equals to k minus 8 over 3. K minus 8 equals to 3. K equals to, oh no, so k minus 8 equals to 0, sorry. K equals to 8. Therefore, coordinates of B is equals to 9, 8. Yeah? Makes sense? A little bit more means actually for y as well divided by ratio. This one is a little bit more practice, just a little bit more practice. Okay, cool. Okay, all right, so we go into question number 13. Question number 13 is a straight line question. If you can see, you can notice the patterns from now already. The papers always have certain questions fitting a certain topic, and it's always 1 or 2 questions, right? For functions, we have 1 or 2 questions. For quadratics, we have 2 to 3 questions just now. Indices and logarithms, so that's 1 question each because they are kind of siblings, cousins. And then right now we're going to straight lines, right? Straight lines so far we have done 1, 2. Oh yeah, we also did progressions. We have 2 to 3 questions for progressions. So you see, you just have to bank on these topics, and then if you know very well, you can do. If you do not know a topic very well, you should know at least out of the 2 questions that settle on topics, try to do at least 1, right? You should know at least that much. Okay, this is very vital. All right, so cool. So now let's go into this. Is the second question, straight line. This is a relatively simple question where they give you 2 straight lines, right? Y is equals to minus 3x plus 8, and the other straight line is y equals to k plus 2, x plus 7. All right. So this is again some more of a comparing coefficient. The keyword here is parallel. Okay, parallel means the gradient m for the first equation, gradient m1, if they are parallel to the second line, therefore gradient should be equal. M1 is equals to M2. That means on a straight line, right, to illustrate that, if the gradient of this is 2, say, M is equals to 2, M1 is equals to 2, a parallel line means that it is in the same line that will never meet each other. But it's a straight line. If you draw a ruler next to each other, they're actually the same direction, right? It can be here or it can be here, but whatever it is, the gradient must be also equals to 2. Only then it can be parallel, right? If the gradient is slightly off by like 0.5, right? Say the gradient is m1 is equals to 0.5. M2 is equals to 1.5. You see, the gradient's a little bit off and they'll touch eventually. A parallel line never meet. Two parallel lines will never meet each other. Okay? So now that you know the gradient is m1 is equals to m2. In this form, it is easy to spot the gradients, right? Because they are in the form of y equals to mx plus c. Right? So m is the number that's hugging x, the one that's literally next to x. So in the first equation, that is minus 3. And the second equation, the number that's hugging x is k plus 2. So since m1 is equals to m2, minus 3 is equals to k plus 2, k is equals to minus 5. There you have it. That's your answer. It's a relatively easy question, you see. It's just a 2 marks question. You should solve this offhand. And the keyword that should strike your mind is parallel. It is parallel to each other. All right? Okay, cool. So there you have it. Okay, minus 5. Okay, now we are going into trigonometry. All right, trigonometry is either you love it or you hate it. Okay, for AddMath especially. It's more of when I was doing SPM, it requires a lot of looking back into the formula sheet because double angles like this and all that requires a lot of memory. But at this point, I think it's safe to say that I've memorized quite a few for trigonometry, right? So you want to find the angle given this equation, okay? If the equations are given which are simple, like sine 30 or sine x is equals to half, right? What is x? You just have to arcsine this, right? Shift sine this. You can do that on your calculator. Just shift sine that. And then you get 30 degrees, right? In fact, there are two answers, 150 and 30. I'll explain that further. Okay, but now you have this equation, sine 2x plus cos x equals 0. You can't do sine 2x equals 0 and cos x equals 0. You can't do that. So you must find a way, you have to rearrange it in some way to solve such that you can come up with something like sine x is equals to half and stuff like that. Then it makes it easier to see and how to use the calculator to like shift sine it, you know? All right. So in this case, you have sine 2x plus cos x is equals to 0. Oh, sorry. Cos x is equals to 0. Okay. For me, the first thing I do for questions like this, for trigonometry questions like this, is to straight look into the formula sheet to see if I can find any relations. So if you look into your formula sheet, I think one of the first things you see is sine 2x is equals to 2 sine x cos x. So then you write it straight away. 2 sine x cos x plus cos x is equals to 0. So I guess the tip that I can give here is that you have to look into the formula sheet for this one. All right? Or otherwise, if you really hate trigo, look at the marks allocation. I'm not sure how many marks this is. I forgot. Look at the marks allocation, and if you really can't do it, try to skip it for now and get back to it later on, where you have time to look at the formula sheet after that. All right? So say I already looked in the formula sheet, sine 2x, I can see that it's actually just equals to 2 sine x cos x. Okay? From here, I can rearrange this further, right? Because I can see like terms, and like I said, in AddMath, like terms are actually very important. You can see like terms cos x and cos x. And then you can factorize that. So you can write cos x, bracket, you take out cos x from this, and you get 2 sine x here. Plus, if you take cos x out from this, it's replaced by 1. Right? So you move, again, you shift this into this. You factorize cos x out. You took cos x out. Okay? And from here, okay, this is a little bit something you have to remember, yeah? If you can see things that are multiplied each other, or like a bracket like this, equals to 0, that means this first term is equals to 0 and the second term is equals to 0. Okay? That's why it's 0, because either one has to be 0, only then the answer would be 0. Right? This bracket couldn't be equals to 5 or 10. And then this one be equals to 5 or 10. Then this wouldn't be 0. Either one must be equals to 0. So then we can write that we can break that down into cos x equals to 0 and 2 sine x plus 1 is equals to 0. Okay, this is something you have to remember. So if you can, usually these questions, it will reach somewhat to this level where it's 2 brackets, right? 1 bracket here, 1 bracket there, sometimes 3 brackets even, and then each of them will equal to 0. All right, so if cos x is equal to 0, you can use your calculator for this. Shift cos 0, right? Shift cos 0. That gives you 90 degree. Okay, but there are 2 answers to that. That's 90 and 270 actually. I'll explain to you why later on. And then for this, 2 sine x will equals to -1. Sine x equals to -half. X, where you get 2 degrees. Okay, if you shift sine -half, I'm not sure if your calculator will give you. Okay, this is what happens when I shift sine -half. If you can see my calculator here, I'm not sure you can see if it's right now. But you see the answer is -30. So you can't write that in your paper, right? -30, it should be a degree. Okay, so before I tell you how to do that, let me teach you a general thing, okay? We have 4 quadrants, okay? And in some quadrants, the sine of some angles or the cos of some angles or the tangent of some angles would be positive or negative, okay? A sine graph, a sine of all the angles, right, will only range from 0 to 1, you know. You can never sine an angle and the answer will be more than 1 or less than 0. Sorry, less than 0 is -1, right? It's always in this range. It can never be less than -1. It's either -1 to 0 to 1. It's always around that spectrum only. Okay, but then sometimes you get -1, and then you must know where the angle lies. Okay, so this is a naming convention that I used to remember because my AddMath teacher taught me. I'm not sure how your AddMath teacher taught you. There might be another naming convention because mine's a little bit inappropriate, but it's fun at the same time and it's catchy. We have this quadrant, okay? A, S, T, and C. A stands for all, means that a sine of any angle in this quadrant, this is 0 degree by the way, 0, 90, 180, 270. Okay. Any angle here, say from 0 to 90 degree, if you sine it, if you tangent it, or you cos it, right, cosine it, your answer would be a positive answer. Okay, you can try it at home, literally any numbers there. In this region, however, from 90 to 80 degrees, only the sine of that angle in that quadrant would be a positive. A tangent and cosine of any angle in that quadrant would be a negative. So that's why S stands for sine, and subsequently, accordingly for T and C. So T, only in this quadrant, only T will be positive, only tangent, and this part only cosine. So how do I remember these alphabets? My teacher once taught me, she said, I remember it through all science teachers are crazy. ASTC, all science teachers are crazy, right? There might be some nicer ways, I'm not sure how you can remember it, but that's how I remember it until now. So all the sine, cos, and tangent of here will be positive. Here only sine, here only tangent, here only cos. Okay? And then further from that, let me erase this. If you use your calculator, if you all can type it out now, try doing shift sine half. Shift sine, arc sine 0.5. You get the answer 30. Half x will be equals to 30 degree. Okay, but it does not limit yourself to 30. That is here is 30 degree, right? The sine of this number, sine 30, will equals to half. But there is another place where the sign of another angle will be positive half as well, which will be in this quadrant, right? That is where you have to know how to add or minus a degree from the answer you got. Okay, so for all the angles, you either plus or minus from this horizontal line. Okay, it's very important here. It's key to remember this. Okay, so if you assign a number and the answer is 30, right? You have to know that it's in these two quadrants, quadrant 1 and quadrant 2. So if it's quadrant 1, you plus 30 from 0. 0 plus 30 is 30 degrees, obviously. And then from this quadrant, you have to times it from 100, minus it from 180. It has to go in this direction. You don't plus 30 from here. Yeah, it's wrong. You have to minus 30 from here. So it's 180 minus 130. So arc sine of half is actually 30 and 150 degrees. There are two answers to that. Okay, this is something to remember. I'll repeat that. Okay, you have to add 30 from the horizontal line from right, and on the left side you have to minus 30 from 180. It's how it works. It's like a butterfly. You cannot add 30 here and add 30 here. That's wrong. So add 30 here and minus 30 here. Subsequently, if it's negative, right, like in this case, right, so if we solve for this, you know that shift sign of half is 30 degrees, but now it is a negative answer. That means it lies in T and C quadrant. It is not 30 nor 150. So how do you do it? The reference angle is again 30, because that's the answer, right? You either have to plus it from here, 180 plus 30, that's 210. Or you minus it from 360. So that's 330, right? So can you see why I call it a butterfly now? It works like that. It's not only for sine, it's for cos as well. And for tangent as well to a certain extent, yeah. You have to plus it from here, minus it from here. Or if it's negative or whatnot, minus it from here or plus it from here. It depends on which quadrant you want to. So the same thing can happen for cos, right? I do not have enough space. I'll just draw a small one here, right? Same things happen for cos. Cos 60 is half, right? 60 degrees. So if cos 60 is half, you have two answers, right? You have 60 degrees, so cos x equals to half, right? X will be 60 degrees. And which other quadrant would cos be negative? Positive. All science teacher crazy. Cos here, right? So it must be, yeah. So you minus 60 from 360. So you get 300 degrees. That's how you do it. It's a little bit tricky, a little bit to grasp on. You can take a screenshot of this. I think it's very useful even for me. So you have the ASTC. You have how it works, the arrows, right? Depending on which quadrant you are looking for. If it's in the first quadrant, you plus 30 and whatnot, or plus whatever reference angle you have. So there you have it. You have 210, 330, and 90, 270. All right, cool. Let's go to in the interest of time. I think this will be the last question I'm going to cover. Vectors, just a little bit of vectors. It's a very simple one as well. It's only 3 marks. Okay, something to understand about vectors is that if you want to move, it's actually just movements, right? From P to S and S to R. So sometimes if they ask you to find PR, it's actually as simple as P to S plus S to R. As long as these two numbers, the two alphabets next to each other join, then you can continue it as a path, right? It's as simple as that. And then things to note is like minus PR is actually just RP. It's the opposite direction. Minus in vector form is actually just the opposite direction. Okay, so with this understanding, let's try to solve for A, right? 15. So what is SR minus vector PR? So you know SR is okay. Yeah, SR, right? So you can find SR. SR is not given a number, correct? But is there another way to go about to SR? Like I said, you can use a path, right, in vector. That's why it's quite interesting for vectors sometimes. Oh, yeah, thank you, Felicia. All science teachers are clever. Cool. All right, so say SR, right? To move from SR, it's not just in one direction. You can go from SP to PR. Do you see? That's why it's actually more like a game. It's like a maze. It's just moving around. It's vectors. That's why I find very interesting about these 3 marks. It should be a given. All right. So SR, you can actually write that as SP plus PR minus PR. Right. So then you look at what is SP. PS is 4A. So SP would be the negative, right? The negative of 4A. PR is 7B. Minus PR is the minus of the vector. So you got plus minus 7B here. Therefore, your answer is minus 4. Right? It's actually, yeah, that simple, to be honest. Okay, so if you do for QP, again, you can try to do it as a path because QP has no direct number, right? How should you connect QP? Right, so you get QR plus RP. And then you would think, oh, but I do not have QR. But in fact, you do. Look at your question. QR is actually equals to 2 times of PS. So PS is 4A, right? 2 times of PS will be 2 times 4A. And you already know what RP is. It's just the negative of PR. 7B. And there you have it. That is your final answer. Right? Cool. So I think it's 5 minutes left to 6. Sorry, we don't have time